In our last chapter, we saw how the Model Context Protocol gave AI agents a way to reach out and touch the real world. By plugging into external databases and APIs, agents finally got a set of hands. But giving an agent hands immediately creates a new problem. You have to teach it how to actually do the work, and you have to do that without completely overloading its ability to think clearly. A developer's first instinct is usually to cram every single instruction, style guide, and edge case directly into the main system prompt. But as that prompt swells past 15,000 tokens, a breakdown known as context rot sets in. The model simply stops paying attention. The core instructions are entirely crushed under the sheer weight of all those conditional rules, and the agent begins to wildly hallucinate. An LLM's active working memory is a scarce resource. When you treat it like an endless filing cabinet, you destroy the reliability of the entire system. The industry's reflex reaction to this memory limit has been to build massive multi-agent swarms. Instead of one agent doing everything, a router dispatches tasks to dozens of tiny, specialized subagents. While that sounds clever on paper, in production, it creates an absolute nightmare. You end up managing brutal deployment pipelines, agonizing orchestration latency, and brittle handoffs that shatter the moment an edge case appears. So how do you get that deep, specialized expertise without the bloat? How do you build a single general-purpose agent that can seamlessly flex into 100 different roles on demand? Adding more agents isn't the answer. The AI needs a completely new way to store and retrieve step-by-step instructions. It needs procedural memory. That brings us to agent skills. A skill isn't a new foundation model or a complex swarm. It is a highly standardized, self-contained folder that teaches the agent exactly how to perform a specific task. If we crack open one of these folders, the structure is incredibly simple. You have a mandatory skill.md file holding the instructions, flanked by optional directories for executable scripts and reference documents. The top of that markdown file contains a YAML block with precise positive and negative descriptions. These act as highly specific triggers, telling the agent exactly when to fire up the skill, and just as importantly, when to ignore it. This creates a clean boundary in our architecture. The Model Context Protocol provides the reach to pull in outside data, and the skill provides the know-how to process it. By pushing complex calculations out of a vague text prompt and into dedicated Python scripts, engineers can force the system to behave deterministically. It shifts the heavy lifting away from the LLM's chaotic reasoning and into standard testable software. This graphic breaks down progressive disclosure. On the left, the Learn Big prompt approach forces the model to process 15,000 tokens every single turn. But on the right, it loads a tiny 50-token header for each skill, keeping the 2,000-token instruction body safely on disk. When a user makes a request, the agent scans those tiny metadata triggers. Once it finds a match, it pulls only that specific instruction body into its active memory, runs the task, and then immediately flushes it back out. The active context stays incredibly small and focused. You can install 50 or 100 distinct skills, and the token budget barely moves. It mathematically cures context rot. This drastically simplifies how engineering teams operate. Instead of spending weeks wrestling with deployment pipelines and orchestration logic, developers can focus entirely on writing and testing individual units of capability. Looking at this deployment flow, you can see how 7 distinct skills are installed directly into an existing coding agent. A single familiar chat interface can instantly swap between highly specialized personas simply by loading different capability profiles. The underlying model is becoming commoditized infrastructure. For an enterprise, the true competitive moat is the depth, quality, and rigorous curation of its proprietary skills library. Giving an agent the ability to dynamically retrieve exact procedural runbooks and execute them against real-world infrastructure creates an incredibly powerful system. But that power introduces a massive new vulnerability. If a developer accidentally installs an unverified community skill, it can silently inject malicious instructions directly into the agent's active workflow. There are internal risks too. If an agent tries to follow a newly updated procedural skill while clinging to an outdated conversational memory, the conflicting instructions will cause the entire execution to derail. Agents now possess near-infinite reach and precise know-how. To deploy them safely at scale, build robust LLM firewalls, assign cryptographic identities, and route through centralized gateways. And that is exactly what we will tackle next.